The project I'm working is violence detection using deep learning. In this project, I'm going to use libraries like OS, CV2, NumPy, and Matplotlib are used for file handling and video processing, numerical computations, and visualizations. We also use train test split from sklearn splits the dataset into training and testing sets. The sequential, LSTM, and other functions from Keras are used for model building. And we have constants such as video frame height and video frame width, which are the dimensions to which video frames will be resized. And frames in sequence, it is used for the number of images should be extracted from the frame. The dataset directory, the root directory where the videos are stored, and the class labels used for classification, which are violence and non-violence. And coming to extract frames, in this function we extract a fixed number of frames from a video file. The steps involved this in are CV2 video capture opens the video and reads the frame intervals, resizes them into image height and image width, and normalizes pixel values and returns a list of frames. And the next is create dataset function. The purpose of this is reads video from the dataset, extract frames, and assign labels. It iterates through each class directory, each frames using extract frames, appends features and labels, and converts features and labels into NumPy arrays and returns them. The next is dataset preparation. This function calls create dataset to extract frames and generate features, labels, and video file paths, saves the features and labels as .npy files, and reloads the saved data using npload, and convert label into one-hot encoding vectors for classification. Next, the data is split into testing and training. The feature train and feature test, these are the testing and training features. Label train and label test, one-hot encoded training and testing labels. Then next, coming to model preparation. The pre-trained MobileNet v2 is a feature extractor. Only the last 50 layers are trainable, earlier layers will be frozen. And coming to the model architecture, it has input layer, time distributed layer, drop layer, flatten layer, and bidirectional LSTM, dense layers, and output layer. The input layer accepts the video sequence of shape, frames in sequence, video frame height, and video frame width. The time distributed layer applies MobileNet v2 to each frame in the sequence independently. Then coming to dropout layer, it prevents overfitting by randomly deactivating neurons during training, and the flatten layer converts the frame level features into a 1D vector. Then bidirectional LSTM processes the sequence level dependencies. It uses forward and backward LSTMs for a better content. And the next is dense layer, which is a fully connected layer with decreasing units. And the last one is the output layer, a softmax layer with 2 units, violence and non-violence. This displays the model architecture with details of each layer, number of trainable parameters, and input and output shapes. The next function is predict video class. The purpose of this function is to predict the class, violence or non-violence of a given video using a trained model. CB2 video capture opens the video file with specified by file path and then checks if the video file opens successfully. If not, returns an error. And then comes the extract frames, determines the total number of frames in the video using cvdo.cap prop frame count, and calculates skip frames window to evenly extract sequence length frames from window. It iterates over the frames, reading one frame every skip frames window, resizes each frame to required dimensions, and normalizes the pixel values by dividing 255, appends and processed frames to framelist function, and make predictions. The framelist expands the dimensions to make it compatible with the model input using np.expand dimensions, and then next calls my model to predict the probabilities of each class for the video. Then next extracts the predict class index and highest probability using np.argument matrix, retrieves and predicted class names and the confidence, and the last one is the code to test function. To test the predict video class function by selecting a random video from the dataset. This function chooses a random class label from class labels using random.choice, navigates to the directory corresponding to the selected frame, picks a random video file from the directory. Then the predict class calls the predict video class function with the path of the video, selected video and frames in sequence. Print the output prediction, prints the predicted class name and confidence, compares the predicted class with actual class, and prints whether the prediction is correct or not. The reference information given down displays the name and path of the video selected for the verification.
This is where we use the model.py for our front-end process, where the users can use the front-end component to detect the violence or non-violence through uploading the video. This is what our front-end part of our project. We can choose the file to upload and we can detect the violence or non-violence by the frames using the deep learning models. Let me choose a file of non-violence video first and uploading the video. It will process the video by frames and by using the deep learning methods. In this video the violence is not detected, so the violence detected as a no. Let me choose another video file. In this file we can see the violence is detected, so the front end part detects the violence as S. The same way here we'll see the violence as detected, so it shows the violence detected as S. This way the results are displayed to the users when they upload the videos, and it detects as violence or non-violence through this. They can use its user-friendly component for the CCTV footages, etc. Thank you.